Then what is its difference between the fundamental gates and the universal gates? If both the inputs are high, the output is low. So this is about the NAND gate. I can construct all other fundamental or basic logic gates, which is fed to the NOT gate, and then the NOT gate performs, inversion happens. Hello students, this is SD Sir from the Temple of Excellence, Vidhyaashram, Pre-University, Mysuru. My today's session is the last session on the chapter Semiconductor Physics, where we will discuss the construction and performance of the universal gates, the NAND gate, the NOR gate, the XOR gate, and so on. Before I could go into the discussion of universal gates, let us try to recall the concepts that we learnt in the previous session, where we understood something called as logic gates. We told digital electronics works on only two possible states, two possible binary states, 0 and 1. We were very clear in telling that there cannot be an in-between state, an metastable state, and 0 always indicates the low state or the off state. 1 indicates the high state or the on state. And we told any electronic circuit which is constructed using the binary levels 0 and 1 was called as a logic gate. And any table which verifies the output of a logic gate is called a truth table. Truth, something which is precise, something which is actual fact. So the table which is actually verifying the output of a logic gate is called as a truth table. And we studied the 3 fundamental gates, the OR gate, AND gate, and NOT gate. We studied their symbols, Boolean representations, truth tables, and working. Under what condition the output will be high, under what condition the output will be low. Continuing my discussion, today we try to understand something called as universal gates. And the first universal gate we understand is the NAND gate. And these are the more accomplished gates in use, something called as universal gates. Now, NAND gate is a logic gate. Again, understand, NAND gate is a logic gate. Again, something constructed using binary states 0 and 1. Then what is its difference between the fundamental gates and the universal gates? Here, NAND gate is a logic gate that can be used to construct all other types of logic gates. Beautiful. Why a NAND gate is called as universal gate? It is that logic gate from which you can construct all other fundamental gates. ನೀವೇನನ್ನ OR gate ಅಂತ ಓದಿದ್ರಿ, AND gate ಅಂತ ಓದಿದ್ರಿ, NOT gate ಅಂತ ಓದಿದ್ರಿ, all these fundamental gates can be constructed using a NAND gate. Therefore, it is universal in nature. And therefore, I say, for this reason, NAND gate has become a standard gate to perform all other logical operations, and hence it is called a universal gate. So please to understand, using NAND gate, I can construct all other fundamental or basic logic gates. NAND gate can perform all the given logical operations. It is defined as a standard gate, a very universal gate to perform other logical operations, and hence it is an universal gate. So if you observe the symbol for the NAND gate, so this is the symbol for the NAND gate. This is the Boolean expression for the NAND gate. And this is called the concise representation of the NAND gate. So as the description goes, NAND gate is a logic gate with an AND gate followed by a NOT gate. So if you observe, students, here you have a NOT gate and this is the NAND gate. So it is a combination of AND gate and the NOT gate. So the NOT gate followed by the AND gate is constructed as a NAND gate. But what you have to observe here is, I have two different systems combined together. Here, there are two inputs, A and B given. First, the performance of AND gate is coming into picture. Why is A and B? Odudwala multiplication, which is fed to the NOT gate, and then the NOT gate performs, inversion happens. To avoid that, we have a single concised system which will directly represent a NAND gate. Eradu ಬೇರೆ ಬೇರೆ operations ಮಾಡೋದಕ್ಕಿಂತ we form a single concised NAND gate which will perform the operation. And look at the expression here that is read as y equals A and B complement. Whatever operation is performed by the AND gate, A dot B, is complemented, is inverted by the NOT gate. Alva? The two inputs are fed to the AND gate. Here, the performance is A dot B. Adan matpura heltini A and B ant karibeko, which is fed to the NOT gate. And the NOT gate is an inverter. It inverts or complements whatever A dot B is performed. So the final expression is y equals A dot B complement. So if I study the truth table here, A and B are the inputs and Y is the output. When both the inputs are low, A is 0, B is 0, both of them are low, the first operation is A dot B. You have 0 into 0, which is 0. But what is the NOT gate doing? It has to invert that 0. So, 0 on complement becomes 1. Therefore, the output is high. So, when both the inputs are low or in the 0 state, the NAND gate will give me an output which is a high state. 0 and 1, A is low, B is high. 0 into 1 is 1. Sorry, 0 into 1 is 0. Again, the output is complemented, which is 1. A is high, B is low. 1 into 0 is 0, complemented 1. 1 into 1 is 1. Inversion happens. Output is low. So what can you analyze from the truth table? NAND gate gives a high output when any one of the inputs or both the inputs are low. If both the inputs are high, then the output of the NAND gate is 0. Therefore, very clearly I have explained that the output of the NAND gate assumes to be 0, takes up a 0 value when all of its input assumes one state. When both the inputs are high, when both the inputs are in the one state, the output of the NAND gate is 0. Now, if any one or all of its inputs are in 0 state, one of the input is 0 or both the inputs is 0, the output will be 1. So this is the description of the NAND gate. So please to understand, NAND gate is a standard universal logical gate because it can perform all logical operations. Here it has a NOT gate followed by an AND gate. It will invert the operation of the AND gate, and very clearly the output of the NAND gate is high when both the inputs are high, when at least one or both the inputs should be dissimilar. See, if both the inputs are high, the output is low. So this is about the NAND gate. Now coming to the next type of gate, which is NOR gate. A NOR gate is a logic gate with an OR gate followed by NOT gate, NOR. So you have an OR gate followed by NOT gate. So very clearly, again, it is OR. This is the NOT gate, which is followed by the OR gate. Now, the output of the NOR gate assumes one state if all of its inputs assume 0, which means to say, now you have a NOT gate which is followed by the OR gate. NOT gate followed by the OR gate, which is the NOR gate for me. The performance of the OR gate addition. So here, when the two inputs are given, addition operation happens. This is an OR gate, A or B. And then when it is fed to the NOT gate, again inversion, complementary happens. So A plus B complementary. So the output of the OR gate is fed to the NOT gate, complementary action, inversion happens at the NOT gate. Therefore, the output of the NOR is Y equals A or B inversion. This is a concise representation of NOR gate. Again, Y equals A plus B. Y equals A or B inversion. Now, A and B are the inputs. Y is the output. When both the inputs are low, see, NOR gate. When both the inputs are low, 0 plus 0 is 0. NOR gate operation should happen, which means the 0 has to be complemented and the output is high. When both the inputs are in the low state, when both the inputs are in the off state, output is high. Now A is 1, B is 0. 1 plus 0 is 1. This has to be complicated. Output is 0. Andre, when one of the input is high and the other one is low, output is also low. 0 and 1. 0 plus 1 is 1 complemented 0. Again, one input is low, other input is high, so the output of the NOR gate is low. Again, 1 plus 1, low. So when will a NOR gate assume a realistic output? Only when both the inputs are low because of the complementation, because of the inversion of the input operation. The output of the NOR gate is high or realistic when both the inputs are low. If one of the input is low and the other one is high, or if both of them are high, then the output is low. That is what we have described here. And this, as I told, is the Boolean expression. Y equals A or B complement for the NOR gate. And the last one is a special type of gate which is called XOR gate. This is a special type of two input logic gate. It's a unique logic gate. Special type of logic gate which has two inputs, which gives an output if and only if the inputs are dissimilar. Observe here. This is the representation of XOR gate. Two inputs and Y is the output, which is the double complement of the inputs. Illi ಎರಡು ಸತಿ inversion ಆಗುತ್ತೆ. Double complementation takes place. So Y equals A double complementation of B. Observe. A is 0. B is 0. 0 plus 0 is 0. First complementation of 0 is 1. Next double complementation of 1 is 0. So the output is 0. 0 and 1. 0 plus 1. First complementation 1. Then again the complementation. See, this turns out to be 0. 1. Again 1, which means in an XOR gate you observe 0 plus 1 is 1. But first complementation makes it 0. Second complementation of 0 is 1. 1 and 0. Again the output is 1, which means an XOR gate yields an output when the inputs are dissimilar. One has to be in the low state and the other one has to be in the high state. If both of them are in the similar states, then we say that it is zero or low output. And the Boolean expression is written here. A double complementation of B. So this is called exclusive OR gate or XOR gate. Unique, special type of logic gate. Exclusive OR gate or XOR gate. So in this session, students, we have understood the three universal types of gates: NAND, NOR and XOR. They are symbols, they are Boolean expression and their performance. In the exam, you may be asked to write the expression for any gate. Write the representation, construct the truth table. If you are familiar with this, very, very easily you can score 1 or 2 marks. And this completes my sessions on semiconductor physics. Next is the most awaited one. Yes, we will start up problems on alternating current. Go through the sessions for that. Be thorough with the expressions. 5 marker. Question number 35 is always from alternating current. Until then, have a nice time. Thank you.